Okay, the same background is present here in problem 2 that was present in problem 1. The triangles are set up for the various reference angles that we're very familiar with, the pi over 6 and the 30 in all 4 quadrants, and then the pi over 4 in all 4 quadrants, and then the last one, the pi over 6, pi over 3 or 60. And you also have your basic unit circle here. With that, you've got your coordinates of the various points. At 0, it's 1 for x, 0 is y, radius 1. 90, 0x, 1y, radius 1. 180, negative 1 is 0. Negative 1x, y is 0, and the radius is 1. At 250, it would be 0 for x, negative 1 for y, the radius would be 1. 0 degrees, 0 radians. 90 degrees, pi over 2 radians. 180 degrees, pi radians. 270 degrees, or 3/2 pi. So that's just kind of a little background for you to reference if you need it. And then we start working the problem. Since this is not just a plain angle, we're going to let A equal everything in there. So then we would have cosine of A is equal to negative 1. Well, since cosine is negative 1, that means x had to be negative 1 and r had to be 1. So if you go up here, x is negative 1 and r is 1 at pi over 80. At 180, or actually that is pi. So you could use pi or whatever. You would use pi because of the expression already has pi in it. So A was equal to that. Then you come back and you replace A with pi because you found it to actually be pi. So you replace A with pi, and this is what happens. You walk through it. You actually get to 3/2 first. But since that's a 2, you make a revolution around. And a revolution would be 4 pi over 2. And 3/2 plus 4/2 is 7/2. And that's where the 7/2 comes from. But you actually want it solved for just theta, because that had 2 revolutions around, so you would have additional answers. You want to get rid of this 2, so you would divide by 2, or you can multiply by 1/2. That becomes 3/4, and that becomes 7/4. Any questions?